So this is a replay of a presentation we did last week around using BDD and ACE. So for those who may not be familiar with the term, BDD is Behavioural Driven Development. First off, I want to say and most importantly, I want to say a special thanks to Trevor Dolby from IBM. This is based on some work that he has done previously. You can read the original code from GitLab here under his projects. We are using basically a fork project with some additional build steps, and we've also converted his project to use GitHub rather than standalone development or standalone building that he was using. So for those who haven't seen much BDD, here's what we Agile and Extreme Programming programmers were talking about when we started talking about test-driven development. So it's describing functionality in business terms, making things more human readable, or more readable by the end user. So what we're going to look now is what we call a feature file. This particular flavor of BDD is using Cucumber and Gherkin scripts, but there are other different flavors out there. So in this case, what we're talking about here is reading what we call a feature file. So we can see the feature file that follows a given, when, then sequence. Now what we can see here, there's actually maps from our feature file into our actual executable engine or executable test case. So if we look at Trevor's original diagrams, what we're seeing here is the test case runner, which when ACE is running his integration test, detects test cases. In this case, it will pick up on the fact that there's a Cucumber test. The Cucumber test engine will identify that there's a feature, and will actually find all the Java code that references the feature. So you notice that the test has no annotation for tests, so these are driven off the back of the fact that it's been picked up by this feature file here. So we'll see here that there's a scenario, which is just a broad description of what this particular test is doing, and then follows the, as I said, given, which in our test case matches to this particular given step here. Now the given step sets up some preconditions before the execution of any sort of test code. So in this case here, the precondition here is the fact that we've set our day, or input data for our day as Sunday. So in this case here, given today is Sunday, sets up some variables indicating that today is Sunday as far as the test code goes. The when is the step that gets executed. So that's the thing that actually changes the state. In this case here, the when is the thing that executes the code, and we'll go through this in more detail in a second. And finally the then, which is the conditions we're testing against. In this case here, we're suggesting that the response should be a no. And we see here in the annotation for the then, there's a bit of matching here. So in this case here, we should match the value in this argument here to this parameter here, which then should be asserted. And if they match, then we'll be asserting true, and the test will pass. And if they don't match, we'll assert false, and the test will fail. Now I mentioned that most of the interesting development work is within this when step. So this here will look similar to what we've got for our ACE unit tests, very similar sort of code. In this case here, we're going to find a reference to our application. So ask our integration server to connect us up to our application, and from that ask it about this main flow, and then we're going to ask it for a node in that name flow called compute. We're going to use that compute node as our testing reference, which means we're going to look at the inputs and the outputs based on our SPI here. We're going to create a message assembly so that we can pass a message to our node. And when I say message here, I mean in terms of the ACE testing framework, not what you would normally see as like an MQ message or a SOAP message or a JSON message. It's the raw XML that manages the state between the nodes of ACE. In this case here, we can load up some data. So in this case here, if we say it's Sunday, then the message is going to look like this that gets passed. We're going to load that data, use the input stream. What we're going to then is building a message from an input stream, so basically load a message up so that we can evaluate that message on the node that it's under test, which is our compute node. What we're going to do is set some assertions. We'll notice here we've got assertions both inside the feature file and inside the then condition, which is the logical assertions of whether or not the logic passed or not. These ones here are validating that the SPY executed. So just to make sure that it actually produced a message. They're both valid failures. One would be a failure of the in the logic of the code, logic of the test, which is these two here, and the other one is a failure of the logic of the code. So they're slightly different, but we need to validate that things are in a sensible state. What we then do is grab the resulting message, pull the information out of the resulting message, and set that into something we're going to validate later. So in this case here, we're going to keep the return result. We're not going to check it against anything, because that's the process that the then step does. And then our feature file, we're going to test our then, which is going to be taking that result message here, which is a local variable to our class, a class variable, and we're going to use that in our then check. Once we've written our logic, what we're going to do, once we've written our logic for a test, we're going to look at our actual code, and this is the code that's actually under the test. This is the SQL we want to test. What I've done now is I've set up a workflow file so we can run this on our CI/CD tool, which in this case is GitHub. So if we look here, we've got a trace file, a trace YAML, which is our GitHub workflow file. So it's going to follow the pattern that most sort of workflows do, which is we're going to check out some code. We've changed it slightly, or tweaked it slightly, because what we're going to do is check out both the code and, in this case, the GitHub wiki, because at the end of it we're going to publish some stuff into the wiki just about this project. So we check out the code. What we're going to do is then run Trevor's component, and I'll provide a link for Trevor's component, which is basically a Docker image with the contents are or contains all the IBM runtimes to actually run this ACE server version 12, which allows these tests to run. Now, because we're gearing this to running on GitHub, while Trevor's was geared to run more just on server, there is some little tweaks I had to do around the way that the bash script set up the profile and whatnot. So nothing saying this is not an issue with Trevor's original code. We're just repurposing it, so we've just had to change it slightly. Trevor's initial code is very valuable. In this case here, we've moved Trevor's logic out into this run script, and inside this run script we're setting up, for example, setting up bash to make sure we've got some valid, we get the appropriate return codes and whatnot from the steps, and then setting up or enabling the profile, which allows our IBM tools to run. Now, the other sort of variation what we've done from Trevor's code, this is some additional steps we've added, and what this is copying in, this is an extra step we've added, and what this does is copy in an additional change to the config file, which allows us to enable tracing. So we can't stop it. We can't start the server and enable tracing before the test runs. Just doesn't quite work that well in trace mode. In the test mode. So we're rewriting, or we're updating the trace, the configuration file to enable this IBM tracing. So this allows us to capture the user trace, which we're going to be using later to report back on test coverage or code coverage for this logic. So we're copying in our specific config file, as Trevor has done, or we've grabbed Trevor's code where we've packaged up the application and run it as a test. Now we have tweaked this slightly, and we've made use of something called T. And what it means with T is we're piping it to both this particular file, which is our test results, and also it ends up being on the output stream. So we've got the output stream in the GitHub job, and we've also got the test results in a file that we can do some grepping against to break the build as required. And we've added this step in our build breaking, which Trevor didn't have. That basically said, if I get an assertion error, then I want to fail this shell script. And that failing of the shell script permeates up to this step here, where we check the valid return code, or check for a valid return code from the shell script. If the shell script fails, because the test fail, then we'll fail this particular stage within the build. And once we fail that stage of the build, the whole workflow build will fail. So we're getting the functionality, we're getting the build breaking functionality. The last step here is assuming that the build's run successfully. We're going to grab that trace file that we'd enabled, and we're going to copy it out of our stage and include it in another stage of the build job, which is using a different component. Now, something we did have to work out is when we copy this file, the ownership of this becomes basically root within the container that the tests are running in, and becomes sort of root, sort of unowned back on the file system that GitHub's actually running the workflow against. So what we've had to do is outside the container, we've had to go reassign the ownership of that, or grab the user we want to reassign the ownership to, and then basically said make everything back in that mapped folder that we've checked out, change its ownership all back to the user of GitHub, the GitHub user, just so the next step can pick it up. These components generally don't run as root inside the container for this one here, for example. So we wouldn't want to mess with the privileges. We didn't want to assign extra privileges to the container for it to be able to change ownership. So GitHub itself, the virtual machine, which is Linux that GitHub starts, runs as root, but inside the containers it doesn't run as root. With more limited permissions, so we can't change ownership here. So once we've got our ownership fixed up, what we've done is we've grabbed the trace file. We're quickly having a look at the trace files and debugging. We've passed that through to our Ant script, and what that Ant script does is it uses the container that we previously built, which contains SonarQube and Ant and a few other tools for handling test coverage and code quality for IRB and ACE projects. We're going to run this trace build, and if we look in here what the trace build does, the trace build sets up a path to our SonarQube plugin, some other jar files required for this process, and then what it does, it says what I want to do. I'm going to produce a coverage file. I'm going to use the trace file that I've produced previously, and this is where my source code is, and this is going to merge the coverage file and the source code together, produce this merge the trace and the source code together, produce a coverage file in this temp directory, which essentially, if I can see here, is going to look basically like this. It's a specific SonarQube format. It basically says, on a particular format, this is my source code, these are the paths within my source code in that particular file that could be covered, and there's some additional information here that we put in here to do with how we manage collecting that coverage. And that's the Ant build. So in this case here, we've run the Ant build. We're just going to validate that the coverage looks correctly formatted, just for purposes of debugging. And then what we're going to do is we're going to ship that source code and that coverage file off to our Sonar server using this properties file here. In this case here, this property file, Sonar project tracing properties. It's just going to direct us to our publicly available Sonar instance to push the results into. It's going to use this coverage file that I mentioned, using this generic coverage report paths, and then what it's going to do in that job is it's going to download the appropriate plugin for ACE and IRB development here from this server, run that using this Sonar scanner command, and put some diagrams in this diagrams directory, and also produce what we call a SARF report, which is a GitHub particular security format for reporting security issues. What we can do then is we can upload that SARF report of any security issues or any particular issues to GitHub, so we can view it in GitHub, and then this document, this diagrams directory they mentioned, we're going to put that into the wiki, and then we're going to see in the wiki, or we're going to reflect in the wiki, some information about our project that the build job is generated. So the build job is going to automatically generate certain diagrams and other bits and pieces into the wiki, so that we have constantly up-to-date information about our project available in our wiki that describes useful architecture artifacts. So what we're going to do now is we're going to jump into our workflow, and we're going to trigger our workflow using GitHub. We could also trigger our workflow using a check-in hook or a time of day or a cron schedule. In this case here, just because for the purpose of demonstration, it's just running it manually, just so we can sort of time it with what we're talking about. So we pick our workflow and run the workflow. So this will take a minute to run, so we'll rejoin once that's finished. So after a minute or two, we can see here that our job has come back as red, indicating we've got an issue. So what I need to do now is go into our job. I also got an email back, but I don't necessarily need to show the email. Hopefully you can take my word for it. We can see here that my job fails. We'll jump into the job, and we can see here there's the step that failed. So if we go through the logs, it's the run with build with unit tests, build test with Docker. We can see the images being pulled down. Here's some debugging. Now we see here these are the app connect logs. We can see we've initialized the server. We're running some other bits and pieces. We've started our test. Let's come back from the feature. In this case here, it's saying I've asked you whether it's Friday, and it's come back and said it's not no, it's no. Oh, so we've got an issue in our logic. So what we want to do now is we're going to jump into our logic and fix our logic to see if we can get our tests to run successfully end to end. So I jump into here to the code. Here's the code under test, and we can see that oh, that's not good. That's not the logic we want. We want to return yes and no. What I'll do now is I will commit the code. We'll push the code back to Git and rerun the tests. So we'll just add the change. Push the change. And what we're going to do now is go back to our job and kick our job off again, or our action off again, just to see if we can fix the build so the tests all pass and the build comes back green. So again, we'll just give this a minute to run, and then we'll have a look at the results. So after a couple of minutes, in this case 3, we can see here that our workflow in Git, or our GitHub action, has come back as green, which is great. So we go back into the actions, or the job. We can have a look and see what it looks differently this time, or looks different this time. Again, we've got the checkout, downloading the container, and we can see here all our tests here in fact green. So we've had is today Sunday, given today's Sunday, is it Friday, and it's no. Now I mentioned that we're going to be uploading this stuff into SonarQube to look at code quality and test coverage. So here's our SonarQube server. So if we look here at what's been uploaded, here's our application. Now there's two things we're going to look at here. One is issues and one is coverage. So we'll look at issues first. So it's missing, so it's uploaded the code and it's looked at the issues that we've got turned on. In this case here we're using what we call a cut down profile with some demo rules. So we've enabled 9 rules. I think there's like 398 there. In this case here we've just enabled a couple just to show you the sorts of things that we're looking for when we're talking about code quality and security scanning. Most of these are self-explanatory. Some of them are very IBM specific or ACE message broker and ACE specific. So copy entire message makes calling copy message headers redundant because you're already copying the message, so you don't need to copy it twice and use the resources to copy the same parts of the tree that you just copied. Copy headers found. Some companies don't like using copy headers. A file does not contain a header, so often companies have like a standard header that they want to see on the top of all their files to indicate the ownership of the file, maybe some description or definition of what the file is supposed to do or the business functionality. Particularly, sometimes they put some change management controls in there, who changed it or why they changed it. Not necessarily everyone's practice, but some companies like to do that. So the first one's a very message broker / ACE specific check. This one here is more of a general purpose coding check. And then we've got the sort of the standard unused methods and unused variables. And this last one here again is another message broker sort of check. And what we're saying here is if you change copy message headers, that may be very confusing for the developer, or potentially the changes could get lost because when you regenerate code, those copy message headers are actually generated automatically, so you could end up rewriting code that you've just written. So avoid using that particular function for any sort of logic. So I said I mentioned we're going to look at the issues in the code. We can see here in this particular file, this particular message flow doesn't have any documentation, and that can come in the form of descriptions or notes. Actually, we'll just go back to our issues. Let's pick another one. Unused method. The unused variable. While I look in here, we can see that we've got an unused variable. In this case here, we've also got. That's going to tell us we've got an unused function, copy message header. We've got another unused function, copy message headers, and in this case here it's telling us that the generated one has some changes, and we probably don't want to put those changes in there because potentially it's going to confuse the developer or they're going to get lost. Now the second aspect we're going to look at is, in this case here, is no duplication. So the next one we're going to talk about here is coverage. So if we look at coverage, we look at coverage, we've got 55% coverage. We're going to look at this file here. We can see that the function was called, which is good. So we've got, our main was executed, but we've got here a branch in our code. So we've got an if condition. If it's Friday, then return yes. If it's not Friday or any other condition, return no. So in this case here we've tested, looks like we've fully tested one branch but not this branch here, and this one here is coming back as partially covered. So we've got some logic that we haven't tested or even executed as part of our feature. So what we'd do then is we'd go back into our feature, add the logic to test the other paths we missed, or if you're running unit tests, go into the unit tests and add some logic to test the path you've missed. We go and commit our change, and we're going to run our change to make sure that we've added a valid test. So we're going to update our feature. Our feature file. And I'm sure everyone's tested that easy to write as just uncommenting some lines. Now we've pushed our change, we'll jump back into GitHub. As I said, more often than not, you'd have a commit hookup in this case here because I'm using a free GitHub account. I like to press the button because I don't want it to throttle my builds at inappropriate times for me. So I'll grab our job. We'll kick it off again and see if that second test helped us. Again, we'll jump back out for a minute. Now the job is queued, just because it might take a few minutes to run. So now we look back at our GitHub workflow, and we see that it's turned green, indicating that our build is finished. And anecdotally, I've also taken the rubbish bins, which was some of the things to do today. So we go back into our unit tests, our build for our unit tests. We can jump back in, look at our tests, and we can see that now we've got 2 tests running, and our second test, Friday, is in fact Friday, which is good if anyone was looking forward to Friday. And if we jump back into our SonarQube project, we can see we've got slightly different coverage now. The coverage has gone up, which is always good. And we jump into our code, and we can now see that both paths through that method have been tested. So we've picked up extra coverage because we've added a second feature test to our logic. So this is the end of the presentation. So hopefully it has been useful. I think the main takeaway I would like to get people from this is that BDD testing and testing that users can understand and the business can understand is actually really important. So if we can explain the logic in terms of business understand, or the business can describe the logic in ways that we can write what we call executable test cases, we'll actually find we've got a far better likelihood of getting the logic right. Because what we often find is when people do write a lot of unit tests, one is often the unit tests are written in such a way just to execute the code, not actually, in some ways, validate that the logic is correct. And the second takeaway from that is often we have unit tests that correctly validate incorrect logic perfectly. So we end up having good coverage, and we can look at the code, and the code looks all good, but what we're actually making the code do is never what the business asked for, or wasn't exactly what the business asked for. So we've actually completely solved the ROM problem really, really well for the business. So behavioral driven development helps us solve the right problem. In the meantime, as I said, thank you for joining this demonstration. If you are interested in finding out more about this testing, or if you'd like to find out more about our products, you can reach us at bettercodingtools.com via our contact page on bettercodingtools.com, or reach me on email at richard@bettercodingtools.com or Richard Hugel at LinkedIn. Again, thank you for joining this presentation, and hopefully you come away with some more tools as part of your more tools to become an improved developer. Thank you.